Well, I'm Michael Escuti, and I'm Associate Professor of Electrical and Computer Engineering here at NC State. And in general terms, I study how light can be controlled by materials and how materials can be controlled by light. Well, if you think about it, there's a number of devices that we have in our lives that involve light as well as electronics. Some of the most obvious things involve the light bulbs, for example, but it also extends to devices like displays that we might have in our pockets, in our cell phones, in our watches, on our TV screens. These are all light and electronic devices together. One of the favorite parts of what I get to do is that I get to imagine and often even invent with my colleagues ideas and then reduce them to something I can hold in my hand. Then I can see it in the real world and test it, evaluate it, improve it. One of my projects involves improving the efficiency, the optical efficiency of displays. And what that means is that we look for ways to take the energy use of a LCD and improve it dramatically. And what that means is that then the cell phone's battery could last, for example, twice as long, or the display could be twice as bright. We use math, in particular geometry and vectors, to describe light. And the thing about light that's always fascinated me is that light is a multi-dimensional quantity. It's not only something that's either bright or dark, but it also has a direction, it has a color, and it also has some of these properties that we can't see with our eyes, but that our electronics can see, called polarization. And so we use math to describe light in an awful lot of ways and to simulate, model, and then even use math principles to guide our fabrication. We use mirrors and other optics to change the direction of light or maybe change its intensity, and so often we'll have an optical element where the light will come in one angle and then go out at another angle, and controlling those angles is best described with geometry, and it rules what happens in optics in general, but especially in holography. Well, there's a lot of aspects of what I do that I enjoy, and one of them is that I get to see with my own eyes what I make. Because I deal with light and electronics kind of together, then when we study a problem and find a solution, we can see it with our own eyes, and that's very satisfying. When I was in high school, I was very fortunate to have exposure to very rigorous math, from geometry to functions to calculus and algebra, of course. And I would say in high school I learned 90% of the math that I continue to use. Yes, I had more math courses in college and grad school, but I'd say the foundation for what I've learned came in high school. And at the time, I would say I tolerated it. I enjoyed it to some extent, but I had to some extent put up with it. And now I can see in my professional life how useful it is, and I'm immensely glad that I took the time to learn the things I did.